In this probability lesson, we are going to look at the probabilities of rolling different sums on two fair dice. Whenever you want to find a probability, you need to first know the sample space. And down here, we have the sample space for rolling two distinguishable dice. So here I have die 1, which can be anything from 1 through 6. Here I have listed die 2, which is also 1 through 6. And we write the outcomes as ordered pairs. So this 1, 1 is when we got a 1 on die 1 and a 1 on die 2. Here, this 2, 1 is when we rolled a 2 on die 1 and a 1 on die 2. Here, this 3, 1 is when we rolled a 3 on die 1 and a 1 on die 2, and so forth. So we can see that there are 6 times 6, or 36 possible outcomes, which means there are 36 elements in the sample space. First thing we want to do is find the probability of rolling a sum of 10 on a pair of fair dice. So we want to know what ordered pairs add up to 10. And notice here we have 6, 4, 5, 5, and 4, 6. So there are 3 out of 36 ways to roll a sum of 10 on a pair of fair dice. Notice that in Excel, if I wanted to convert it into a decimal, I precede the computation with an equal sign. So a probability is 3 out of 36, or equivalently 0.0833. Now let's find the probability of rolling an even sum on a pair of dice. So we want to count how many of these give us even sums. So we see 1 plus 1 is 2, that's even. 1 plus 2 is 3, that's odd. 1 plus 3 is 4, that's even. 1 plus 4 is 5, that's odd. 1 plus 5 is 6, that's even. And we notice this pattern of every other one is even. So we're going to get then that half of the 36, so 18 out of 36 give us even sums, so the probability is 1/2 or 0.5. Now let's find the probability of one die coming up even and one die coming up odd. When we were computing the probability of an even sum, note that we got even sums when both the dice had odd values, 1, 1, 1, 3, 1, 5, or when both dice had even values, 2, 2, 2, 4, 2, 6. Whenever we had one die coming up even and one die coming up odd, we got an odd sum. 1 and 2 gave us 3. 1 and 4 gave us 5. 3 and 4 is 7. 5 and 2 is 7. So we see that the remaining half of the outcomes have one die even and one die odd. So 18 out of 36 to give us the probability of 1/2. Okay, how about the probability of rolling a sum of 4 or a sum of 8? This is an OR problem, so what we need to do is add together all the ways to get a sum of 4 and all the ways to get a sum of 8. To get a sum of 4, we have 3 and 1, 2 and 2, and 1 and 3. So 3 ways to get a sum of 4. Plus, to get a sum of 8, we have 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. That's 1, 2, 3, 4, 5 ways to get a sum of 8. So a total of 3 plus 5 or 8 ways to get 4 or 8, and that is out of the 36 possible outcomes. So we get a probability of 0.2222 of getting a sum of 4 or a sum of 8. Next, we want to find the probability of rolling a sum of 4 and then a sum of 8 on consecutive rolls. This involves an and when we want to find the probability of a sequence of events, we use a product rule. So first thing is the probability of rolling a sum of 4. Recall that was 3 out of 36. And, which is times, we want the probability of rolling a sum of 8. Recall that was 1, 2, 3, 4, 5 out of 36. So we multiply the two probabilities together, 3 out of 36 times 5 out of 36, to get 15 out of 36 squared, or 0.011574. So whenever you have an and, it's a product rule, and you want to multiply the individual probabilities. Whenever you have an or, there is an addition rule, and you will be adding some outcomes. Let's look at the probability of rolling doubles. To get doubles, you get double 1s, 2s, 3s, 4s, 5, or 6. So we can easily see that that equals 6 out of 36 ways, or 0.16667. The probability of rolling doubles on 3 consecutive rolls. So that means the first roll is doubles, which is 6 out of 36, and, which is a product rule or multiplication, the second roll is also doubles, so that is also a 6 out of 36, and the next roll is also doubles, that is again a 6 out of 36. So we have 6 out of 36 multiplied by itself 3 times to get 0.00463. We could have also done an exponent. We have, notice, equal open parenthesis, 6 out of 36, close parenthesis, raised to the third power. So 6 out of 36 raised to the third power is 6 out of 36 multiplied by itself 3 times to give us the answer 0.00463 again. So 2 different ways we can do that one. How about the probability of rolling double 6? Well, of the 6 ways to get doubles, only one of them is a double 6, so we only have 1 out of the 36 possible outcomes is a double 6, so 0.02778. Now we want the probability of rolling double 6 on 2 consecutive rolls. So we already saw that that was 1 out of 36 for the first, and, or times, 1 out of 36 for the second roll to get 0.000772. We could have easily, just as easily, done 1 out of 36 squared, since it was multiplied by itself twice. Don't forget to put parentheses around the fraction, and we get the 0.000772 again. Finally, we want the probability of rolling a sum less than 7 on a pair of fair dice. Notice we get sums of 7 here on this longest diagonal. So less than 7, here's 6. There are 5 ways to get a 6, 4 ways to get a 5, 3 ways to get 4, 2 ways to get 3, 1 way to get 1, 1 plus 2 plus 3 plus 4 is 10, plus 5 is 15. So we have 15 out of 36 ways. So 0.416667, and this is just some examples of probabilities you can do rolling a pair of fair dice.